The broadcast is now starting. All attendees are in listen-only mode.
Hello, thank you for joining us for this session, Understanding the Feasibility of Getting to Zero in School Retrofits. I am Connie Umphris, Communications Manager at New Buildings Institute. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. Please ask questions in the same question pane as they come up. We will have time to ask questions at the end of the presentation. At the end of the session, you will also be given the opportunity to take a short survey. Please take a moment to answer the questions as it helps shape upcoming events. If you are seeking AIA credit or need a certificate, the survey is the place to let us know. This session is being recorded, and the link to the recording and a PDF of the slides will be sent in a follow-up email tomorrow. I'd like to pass it over to Riley Loveland, Project Manager here at New Buildings Institute, who will introduce our topic and speakers. Riley, over to you.
Thank you, Connie, and good afternoon, everybody. As Connie said, my name is Riley Loveland, and I'm a project manager here at New Buildings Institute, and welcome to our third webinar in our Getting to Zero Schools series. As Connie mentioned, for those of you seeking continuing education credit, please let us know in the survey, and here are the learning objectives for today. Participants will be able to identify and utilize lessons learned and process approaches from successful zero-energy school retrofits. Participants will understand how site assessments for zero-energy retrofits are different from typical walkthrough assessments. And participants will understand that how energy consumption is split between regulated and unregulated loads in conventional buildings and how this differs from energy consumption in zero-energy buildings. And participants will gain a greater understanding of the importance of operations on a zero energy outcome. I'm excited for the last one. So many of you are familiar with New Buildings Institute. You've probably been on a couple of our webinars before, but the kind of key piece that I want to pass on to you guys here is that our work, I wanted to provide some context based on the research that we do at NBI. NBI maintains the largest database of zero energy buildings in the nation, and as such have been able to identify some of these common themes across successful zero energy, new construction, and retrofit projects. And today's presenters will really dive into what I'm going to talk about here, but I just kind of wanted to give you a brief overview, and they'll tell you how to apply these concepts. These key themes here will help guide your successful zero energy school retrofit process. Number one is making a commitment and gaining that stakeholder support so that you have support for your zero energy vision. Ground your decision-making and planning in efficiency first. Establish clear and absolute energy goals that can both be designed and operated to. Benchmarking all of your facilities to understand how your baseline or how your schools are performing so you understand your baseline and the potential for energy efficiency upgrades. Performing strategic portfolio-wide energy planning by utilizing things like system lifecycle opportunities, bond measures, stakeholder turnover, and other district construction plans. And then continuously seeking improvement by continuing to measure your building energy use regularly and report it out to your stakeholders. And the last one, this is kind of the most important one, is involving students, because remember that these buildings are designed to educate students, not just to operate as facilities. And these buildings can provide these hands-on learning opportunities for students to develop 21st century skills. And they really have shown, we can provide the data, and we've actually done this on a previous webinar. They have shown to increase productivity, health, and wellness outcomes in both students and staff. So I would like to introduce today's presenters. I'm really excited to introduce these two. So Farah Farzaneh is the Sustainability and Energy Manager at San Bernardino Community College in San Bernardino, California. And Philip Saig is the Regional Director of the Rocky Mountain region of the McKinstry office. And one more quick thing before I pass it off to you guys. For those of you seeking resources about how to get your zero energy retrofit or new construction project off the ground, NBI hosts the Getting to Zero Hub, which offers a whole suite of resources for zero energy schools. The hub highlights outstanding policies, programs, and strategies for school districts pursuing zero energy. And it includes information about developing energy targets and template materials on how to use them in practice, as well as technical tools, guides, case studies, and fact sheets to assist in your efforts. And that is all from me. So Philip, I'm going to hand you presenter here and pass it off to you.
Great, thanks so much, Riley. Can you hear me now? This is Philip Sig.
We can hear you.
All righty, good. Well, good afternoon / lunchtime to everybody out there. Just want to start while she gets the slides up here. Just want to start by saying thank you for having me. Excited to be on this webinar and share a little bit about some of my experience and our experience working with specifically Boulder Valley School District. That is in Colorado. If you haven't been to Boulder, you should go. It's unlike any place you've been before, as the folks around here locally will tell you. Before I jump in, I wanted to say a couple things, which is one, this presentation was put together by myself as well as the energy manager at Boulder Valley School District by the name of Jeff Medwitz. So give credit where credit is due. Jeff's background is as an architect, and he provided a lot of the beauty, as you might see in some of these slides, like this great logo here. At any rate, jumping in, I've gotten a chance to work to put together a strategic approach for zero net energy for this district, starting really back just before 2014. Before they passed the bond that helped them implement a lot of what we're going to be talking about in the next 15 to 20 minutes. So with that, let me see if I can get this slide to advance. So a couple things I'll talk about is first, explain the strategic energy plan they have at the district that they created, the strategies to execute both zero net energy in new schools as well as deep energy retrofits. And I'm going to talk a little bit about the difference there, and then describe some of the setting up and delivery of the integrative design process. And for those of you who've been in the industry and delivered some of these projects before, I'm sure you'll agree with me that an integrative design and construction approach is extremely critical to driving low energy buildings. Also, what I'll say too is, what I want to talk about actually in my portion of this is fairly process oriented, kind of the setting the stage for how to do this. I'm not going to dive too deep into details of specific, say, design measures or energy efficiency measures around mechanical system selection and how to do that, or lighting power density loads per square foot or plug load strategies. I think Farah is going to get into some of that specifically in her presentation after, but I'm going to kind of set a process stage up for you guys, at least share my experience. So first of all, a little bit about Boulder Valley School District. About 56 schools in the district. You can see here, this is a map of Boulder Valley County, or Boulder County, just north of the star there, which is the city and county of Denver. School age is really ranging from 1882, so pretty stinking old, all the way up to their newest school before this bond was built in 2011, and we've built some new buildings here in the last couple of years we'll talk about, obviously. Just to give you a perspective, this is a chart showing you the EUIs of the different average EUI of school districts in Colorado. So see, these are some what we call the front range school districts, the larger school districts in and around Denver. You can see Boulder Valley is highlighted there with an average EUI of 71. So you kind of see where it stacks up against its peers. Not particularly efficient in the state. And that's changing now. And so they've set goals to do by 2019, which is this year. Now they're giving this presentation. Sometimes it blows my mind how long it takes to get through design and construction projects. But I think the goal was to get 20% reduction across all 56 schools by this time. And I am happy to report, I think they're on track and we're doing that. And I'll show you some of the before and after numbers and actual utilities when we get to it, and then kind of on this larger trajectory for 2050 zero net energy. And how, when we say zero net energy, kind of how we're defining it, really is producing more energy than consuming on the site. As New Building Institute is an expert on, the Department of Energy are experts on getting into the definition exactly of what we mean when we say zero net energy or zero net carbon in this case, or you saw Z&EC, or zero net energy capable, where what that means is we're really driving low energy buildings into the maybe for schools, maybe the sub 30 EUI range, and then putting plans in place to allow renewables to come in at a later date. So you can kind of see the chart here on the left. You can kind of start to see where things stack up on this nice ZEPI chart. BVSD goal you see at 25 right there. That's really what we were targeting here. And obviously the equation for things that use energy divided by the gross square foot gives you your kBTUs per square foot per year. And you want to balance that out with your production of renewables, whether that be, in our case, it's pretty much all solar to be able to do that, and geothermal to support the system in some cases. Not a lot of micro wind availability where we are at. So I talked about it was, the 71 average across the district, and then, bringing that into now a 60, well, I guess the 71 is the 2014 data, and then at the time we started this, which is, just a year later, it was down a little bit to 68. Across the United States, we see this average to be 58, so we're worse than average as a starting place. And then now in 2019, that 20% reduction, what we're shooting for is a 55 average EUI right now. The most latest school that was built previous to this bond was Casey Middle School in 2011, and that came in at a 32 EUI. And so really by 2050, we want to get all the schools to have that sort of sub 30 EUI averaged out across the district. So, better than even their best performing school. And, Riley talked a little bit about this in the intro, this idea of really being clear about benchmarking and setting an energy target. I think this is a really important piece to why these projects were successful, being able to set those targets both at the individual project level, but also at the larger district level. There's nothing unusual about this bond either from a school district bond perspective. It's fairly typical for those of you listening that are managing and doing work in schools. The deferred maintenance or the deficiencies needed in the district were just over 800 million, and the bond that was approved in November of 2014 was 576 million. So, significantly less than the need. Budgets were tight on these projects. They, went through rigorous, value engineering and all kinds of good stuff like that we're all used to. This was actually the 576 million is the largest bond ever passed to date at the time in the state of Colorado, but still not big enough to cover all the necessities in the district. So where that money went. So what do we spend this 576 million on? So kind of Jeff's vision for this, and what I got hired on and got a chance to implement with him in a strategic way, is really categorizing new facilities, deep energy retrofits or gut renovations, and then smaller onesie twosie deferred maintenance projects that we call sort of our retro commissioning projects, if you will. So first we had these new facilities. We had these 4 schools, brand new, 3 of which were being built next to existing older schools from the late 1800s and early 1900s that you see there, Creekside, Douglas, and Emerald. Roughly 60,000 square foot facilities, and then a little bit of larger K-8 facility, which was an additional school to handle new capacity or growing population. In addition to the 4 new schools, we built, these ones are actually still in progress, Central Kitchen and Ed Center. And then there's a third that's not on this list on that same site, their Transportation Center as well. So more administrative and support facilities that were being built from the ground up as well. Then we had our deep energy retrofits. So we kind of had to come up with a definition of what the heck does that mean? When we have a deep energy retrofit, it means we've got big capital going on in that building. We're going to touch them. We want to replace the mechanicals. We want to touch the envelope, and we want to sort of mitigate our energy hogs in the district. Then finally, where we just had deferred maintenance spending in schools that was replacing of, say, 3 or 4 air handling units on a school, or some heat pumps or something along those lines. What we did there was really perform sort of a retro commissioning study beforehand, understand what we're dealing with, and then when we replace that equipment, then commission it and make sure the sequences are written in an efficient way from an operations perspective. So those are sort of our three categories, and sort of try to apply this integrative design process to at least the new schools and the deep energy retrofits. We didn't really do anything with integrative design on the sort of retro commissioning or small deferred maintenance projects. But what this meant to us first was we wanted to have some workshops, and we really broke this up into two major workshops. We had one with all the new schools, and then one with the deep energy retrofits, which there was, 6 of those about in the district. And so we were brought on, and then the last kind of thing here is energy consultants. So we were brought on actually before the architect and design engineer and the design and construction teams were brought on, and then the GCs were brought on really right about the same time the design and engineering folks were brought on. And so that process allowed us as an energy consultant to, one, set up this culture, set up these workshops, kind of hit the ground running, create these EUI targets, really get some of that stuff figured out before we hit the design schedule limits and brought the design teams on. And it also allowed us to do audits, kind of higher level audits, and a little bit of modeling, but really just gathering of the audit information, as you can see in this chart below, before the design and schedule hit. Because honestly, like I said, this is a typical bond. The schedule constraints on renovating existing schools, the summer construction schedules that you've got to work with, and the schedule we had, frankly, from the time we got the bond to when occupancy was in the replacement schools and new schools was not long. These are very fast-paced projects. So we had to, as an energy consultant, work with the district to audit these facilities ahead of time, understand both what the bond dollars were, but also what their technical potential was, or just how darn efficient in a best case scenario we could get these buildings. And then when the teams came on, the design teams, we could work as that energy modeler to start quickly iterating their design ideas in an active energy model. And this is an example of that. I just pulled up one here for you guys. This is Creekside Elementary School. What we did here, you can see along the top there, you've got options 1, 2A, 2B, option 3, and option 4. And what this really is we were modeling and working with the district to create a selection criteria for which mechanical systems and our energy systems were going to go into these facilities. So you can see in this case, option 2A1, it had a final score of 8.2, so the highest, which was a displacement system with hydronic heat, dedicated outside air. And we chose that system not based on 7 criteria. So this wasn't just what's the most energy efficient. We had to take into consideration a holistic approach. So, you can see there some of the things, hopefully. First, cost, constructability, what the EUI was, so the energy component, maintainability. The district had tech specs around, no evaporative cooling on the rooftops, and specific, are they relevant systems? Are they things the maintenance team knows how to work with? Or are they super unique one-off type system selections? What's the ease of repair? Are there technicians available? Some systems, for example, like a variable refrigerant flow systems, we've got to assess, are there qualified technicians servicing the area and things like that from those companies. We want to look at future proofing, so hedging against future energy price volatility. What are the operating costs in total? So it's maybe the simple payback. And then, of course, the indoor environmental quality, which Riley talked a little bit about, building wellness as well, the intro to this. So that was all important factors for us getting into this, that this was sort of the scorecard that is informed by our energy modeling, financial modeling, as well as some of these other criteria from the technical specifications, and frankly, the operations team's opinions that could be, you can see some of these scoring could be a little bit more subjective from the owner, from the district, on which system to select. Then kind of moving along, if I can get this slide to advance, this is kind of how we ended up, which I'm proud to say is, I think, a huge benefit to the district. What you see here are the new schools as well as the deep energy retrofits. Kind of starting from the left, Meadowlark that's like the Erie K-8 school, is just renamed Meadowlark. Broomfield, which was a new school, and then Broomfield Heights Middle School, which is kind of behind the words there, but that was a deep energy retrofit. Broomfield High School retrofit, then Emerald, Boulder, Douglas were all the brand new schools, and then Centuris, Fairview were deep energy retrofits. Creekside, we just showed you the energy modeling scorecard for, was a new school, and then the transportation center. You're looking at a modeled result on that one because it's not yet complete. So really the blue chart was our baseline EUI, and then our actual EUIs are here in the orange. And in some cases, like the transportation center, it's predicted, but the rest of these we've got actual data for, and happy to report, some of these EUIs in the 20s and 30s are huge reductions on some of these retrofits, as well as, the new schools. And the new schools are against what the, 3 of them are replacement schools. So this, and they're the same square footage. So like Creekside, for example, the 99 was the existing utility spends, the actual utilities they were spending or their EUI in that school when we replaced it on the site right next to it. Whereas the only new one, this Metal Arc one that didn't exist before, 57 is sort of your ASHRAE 90.1, sort of code model, which is maybe a typical way against showing these numbers. So happy to report that, pretty successful on the project. And then from a financial standpoint, just highlighting a couple here, you've got, this shows anticipated utility savings versus a code compliant building or a 90.1 model. And then, so, you can see significant year-over-year savings in these schools. And this is just highlighting a few of them on this slide. And then the line chart there is incentive from the local utility. So that's a one-time check from the utility that we were able to submit our energy models for and show performance on these schools and get a sort of pay for performance rebate from the utility. Kind of moving along here, try to keep time. Just a couple takeaways from this, and I've got some more detail I'll jump into in a minute, but if we expect buildings to perform significantly better, we need to change the process by which we do them. It's just, the reality is, and it was really great that Boulder Valley had the vision to bring us on and to kind of set these goals themselves even before bringing us on to talk with them and set these goals up, because really what we were able to do with the project managers at the district, as well as the operations team and as well as the design teams when they came on, is just like, hey, if these schools are being managed and being built, to EUIs in the 70 to 100 range, and we want them to be in the 20 to 30 range, we just can't do it the same way. Now, the bond's got to be the same. We can't change that necessarily from a timing perspective, and the schedule can't change. But man, our process sure can change. And so I think that was a huge kind of do different for us. That integrative approach really then led us to this last kind of component on what we call active energy management, but is really sort of a 1-year post-occupancy tune-in period. Because as maybe many of you know, best laid plans, right? You get your design figured out, even you get your models dialed in, and the building just isn't used or isn't performing exactly like you thought it would during those early phases of design and modeling, because frankly, if they thought the school wasn't going to be occupied during the summer or be used by the community a certain amount, we predicted certain loads and schedules got expanded to accommodate those things, or during construction we had to make decisions and change some certain equipment that went in because of budget process, and that we really need this tune-in period that we call active energy management for at least the first year of occupancy. And the key thing here is to basically kind of pull a string of continuity across all of this. That early on in the planning and before we even start design, we've got the end in mind, we've got our goals set, we've got processes in place to do that, and we revisit that and we string that through commissioning and M&V and all the way into post-occupancy of these facilities, so that we are really dialing in against our original vision. And having that continuity is really, really important and gets lost in the design and construction world. As you know, these handoffs from design to construction, from construction to operations, there's so many missing things. It's really hard to get this level of continuity of performance when you're trying to drive performance from day one all the way through. And that's what we were able to do because we were on board to sort of own that aspect of it this whole time. So that was was a fun position to be in. I do want to talk to back up even more about really assessing the budget in these. And I said I'd talk a little bit more about process than equipment selection and that type of technical details. And this is where we actually augmented maybe the facility assessment process. So you really got to zoom out and think of, how did that $576 million get put together? How does the bond get put together? Well, on the top here is the typical process we see, and not just for school districts, but for higher ed as well, and government entities and other public agencies. Is, you kind of do facility assessments, you collect some baseline data, you assess life of the equipment or when it needs to be replaced, what you think that's going to cost, and you quantify and you build up that deficiency list. And in this case, it was 800 million and needed to be prioritized down to 576. But nowhere in there is this idea of performance. It's just sort of when's the equipment going to sort of die in the vine, and how much is it going to cost to get it working again. What we did is we said, hey, let's analyze energy consumption. You can see sort of the green highlights at the new process in the bottom. Figure, do some total cost of ownership modeling and start going, because these are, by the way, institutional owners. They're not planning on selling the schools anytime soon. So instead of just figuring out what it costs to replace these, let's take a more holistic approach and look at these buildings as their assets and how much they cost to run and how much value they provide. And so what we did is we said, let's analyze energy consumption, as well as assess the design intent, or say the technical potential, which I talked a little bit about earlier, but really figure out how good could these schools be just in a perfect world, and then start to identify new systems approach. So instead of saying, hey, let's just always like for like replace, there's 33 air handling units that need to be replaced on this school. What's that cost to replace 33? What are 33 new ones cost? Instead, we're going to say, maybe a whole new system needs to be put into place here. So that's kind of this bond needs, which, hey, typical bond kind of prioritized list here. You can see all the things and how much they cost. Look at maybe what the savings potential is, and then start to create that audit and model process to say, what's the technical potential in this facility? And so this is a picture of, I think it's Broomfield Heights Middle School, where we created an energy model and said, hey, what could we do with that school? And then create those different iterations. Sometimes we had to adjust the baseline. This is more of a detail, but we did have to adjust the baseline in a lot of these schools because they didn't have enough fresh air in them at the time. So we actually needed to adjust the baseline up. When I say adjusted baseline, I mean, we had to add fresh air into these schools, which we take an energy penalty for on an absolute ZEPI scale. So then we design and build. This is an image of the Broomfield Heights Middle School example, kind of what that 21st century learning environment could look like. This has ended up what it looked like. And then one just quick example, and I'll end my part here because I know I'm running short on time, is, one example we did to tune in facilities through the active energy management program is we started to write analytics and monitoring of equipment performance. You're looking at a schematic of an energy recovery ventilator here, hot air and cold air transferring heat out to recover that energy or that heat and stick it back in the building to save energy. So, we wanted to make sure that was performing. So what we do is we write specific analytics or algorithms that look for performance deviation, and then we act on that when we see it. So I'll just walk through this slide. On the far left here, you've got there in this building, there were 4 ERVs. So we've got our 4 there along the left. Then we've got the rule we've written in the software or the analytic that says, we wrote about 20 analytics for each one of these schools. And, in this case, there at the top there, you can see 2 analytics for that first ERV were triggered. Then we want to know for how long were they triggered, how long were they out of their performance expectations, and then when did that happen? In this case, specific day. You can see right there, I just highlighted this little section in the green there where the heat wheel speed was not maximized, meaning we had an opportunity for the heat wheel to be working or running, and it wasn't. And so we click on that, or our team dives into that and says, let's trend those points and look at that information. You can see where the mechanical cooling turned on there with the blue arrow, and the heat wheel is off. So we would have expected the heat wheel to ramp up with that cooling turning on so that we could take advantage of that efficiency measure, and it wasn't. So this gives us an opportunity to go on site, figure out what's wrong in the logic and the sequence, maximize that heat wheel use, and then tune the building in and for energy performance. So just one example of a post-occupancy thing. So thank you guys very much. I know I tried to cover a lot in a very short time period of time. So if you do have any questions, please feel free to reach out to me. My email address is up here, and I think Riley's posting the presentation to the MBI site. But happy to take any questions or comments either at the end of this presentation, or feel free to reach out to me afterward. So thank you guys so much for listening, and I'll pass it back to you, Riley.
All right, Farah, you're up.
Oh, thank you, Philip, and hello, everyone. Thank you for joining us today. My name is Farah Farzaneh, and I'm the Sustainability and Energy Manager for San Bernardino Community College District. And I'm very excited to be able to share with you a little bit about SBCCD's journey to achieving zero net energy. We are very proud to be the first and only CCD in Southern California to be a part of Prop 39 Zero Net Energy Schools Retrofit pilot program. This program is funded by California investor-owned utilities. This is California's program to demonstrate that technical feasibility of zero net energy is possible in a retrofit in public schools statewide. Next. All right, so today I'm going to tell you about SBCCD and our sustainability culture. Then I will introduce our team to you, because frankly, without the team, this project will not happen. And I'm very grateful to be working with talented and passionate group of individuals who are dedicated to learning the best practices to achieve zero net energy. I will then review CABNES analysis with you, which was the basis of our energy efficiency measures that were implemented. Then I will go over the cost of ZNE measures that were implemented, followed by few examples of the energy efficiency measures that we have completed. Next, please. All right, so who is SBCCD? San Bernardino Community College District is one of 72 community college districts in the state of California. It has 2 out of 114 California's world-leading goal of carbon neutrality by 2045. SBCC has begun a journey towards achieving zero net energy on its campuses. In 2012, sustainability plan was adopted. This was a result of long-term dedication and commitment by SBCCD visionaries to the future of their students. And the 7 goals listed here are what we started with. It does take visionary leaders, people who really care about the future they leave behind, to be willing to allow their employees, their students, their teachers to get a little uncomfortable, to become early adopters of emerging technologies and participate in the ZNE pilot program. Our visionaries are our board of trustees, our chancellor, Bruce Barron, our executive vice chancellor, Jose Torres, as well as our college presidents, Diana Rodriguez for San Bernardino Valley College and Kevin Horan for Crafton Hills College. Now meet our implementers, our utility partners, and our contractors. If you are involved in energy management at any UC, CSUs, or CCDs, you have probably worked with Lisa. She's our Southern California Edison account manager. Other team members are Gustavo in the middle with Southern California Gas Company. In the bottom of the screen, you see Robert and Ephraim with Southern California Edison, who worked very closely with me on this pilot program. Partnership with utilities has been tremendous help in this effort. Not only they provide additional funding, but they also assisted us continuously by providing technical advice and technical support. For instance, Ephraim has been involved in the implementation of this program from the very beginning. He attended every job walk, every project kickoff meeting, and Robert came to our site so many times, and he looked at our progress and he gave us his technical expertise. Listed on the left are our contractors. These guys worked tirelessly to implement the energy efficiency measures. They were working on tight budget and schedule, and mainly working at nights and weekends. Now introducing our technical advisors, because these guys are the designers. They make it happen. They made our vision come to life. So it started, and it includes both Southern California Edison as well as SBCCD's technical consultants. It started with CABNES. CABNES, bottom left, she audited 2 buildings, gathering performance information on major energy consuming systems such as lighting, HVAC, domestic hot water, and plug loads, and identifying proposed energy efficiency measures that we will see in the next few slides. Based on her analysis, it showed that our existing site EUI was at 41.5. But and then she also, based on her analysis, she said that if we implement all of the measures that was identified, we can bring down our site EUI to 23. Arab, Martin with Arab, is our sustainability and energy consultant for all the Z&E measures. HMC architect Ken came on board to design the layout for our tubular daylighting system as well, and the controls. NG Design, Gregory, with NG Design, our HVAC upgrade system, including building management system. And now that most of the measures for HVAC lighting, daylighting have been implemented, Noretsco, Rick and Andrew are implementing the measurement and verification. All right, so listed here are manufacturing partners. The operational team is leveraging Z&E technologies and innovations by having several of our manufacturers work together for the very first time, integrating their products. For instance, solar tube daylighting system and its connection with EnOcean wireless controls was tested for the very first time on this pilot program. We also had MecoShade and ThermoShade working together to provide automated solar shading, which I will tell you a little bit more about later. But what's important to remember is that all of the systems that have been tested and have been integrated and working on this pilot program can easily be replicated at any educational facility nationwide. Next, please. This pilot program has 4 main objectives, and they're all listed here. But in summary, Prop 39 pilot program exists to prove the feasibility of Z&E retrofits across California and to disseminate the lessons learned to drive Z&E to scale across the state. Next, please. All right, so this is Cadna's recommendation. She recommended 10 energy efficiency measures to be implemented. As you can see, most of the measures are about HVAC upgrade, installing solar shading, LED lighting upgrade, installing light tubes, and as well as tankless water heaters. Pending completion are pre-coolers and plug load installation. This slide represents the cost of Z&E, or the cost of implementing the energy efficiency measures. Our funding sources were mainly from Prop 39 initiative, state fund block grants, and then Z&E pilot program allocated $300,000 for the implementation of these measures, which is approximately 14% of the cost. All right, so this pie chart represents our approach to zero net energy. It is a hierarchy of ways you want to start looking at interventions for your project. You start by load reduction, such as looking at the facade and finding ways that you can limit unwanted solar energy entering the building. Then you move into passive strategies. From there, you move into efficient systems, such as efficient HVAC and controls. Then you look at opportunities for energy recovery. And you finally start looking at your renewable energy. The goal is that by this time you have driven energy down so much that you have a much smaller system, which is more cost-efficient approach. SPCCD followed this approach. If you're just looking at mapping the energy efficiency measures that I just went over quickly before in the slide before, we have automated shading, which is the load reduction strategy. We have light tubes, which is a passive strategy using natural daylight. Also, upgrading to tankless water heater is also a passive strategy. And then we have active strategies, such as LED lighting retrofit, as well as upgrading to ultra-high efficiency rooftop package units. As you see from this pie chart, most of our effort was focused on improving efficiency. All right, so the bar to the left is representing the existing energy uses of the facility before any measures are implemented. The next bar is scaled up to represent source energy, which accounts for our total energy use. Next slide, please. Then you're looking at the third column. As we begin implementing the energy efficiency measures identified, it's expected to bring our energy consumption down as much as we can. Next slide. All right, so now we start looking at renewable energy. We have 174 kilowatt PV array at the project, and the yellow bar represents the estimated energy that it will produce annually. If the two bars to the right of the screen were at a level, you would achieve zero net energy because you're producing as much energy from renewable sources as you're consuming. In our case, in this case, it's giving us some margin. If we implemented all the energy efficiency measures then we would actually be net positive. But in reality, because we are not implementing all the measures as prescribed due to budget constraint, we're targeting zero net energy. For instance, Cadmus recommended installing about 107 light pipes. We're really installing about 18 because we didn't want to spend $900,000 on it. But with installing 18, we get to test the system, and I will go over that with you a little bit later. Next slide. As I said, we have a 174 kilowatt carport system that was provided by SunPower. It has an added benefit of reduction of heat island effect. It's been operational since February 2018, and so far the production has met expectation, and we feel we're on track. LED conversion was the first project to be implemented as it offered the single greatest potential to reduce site EUI. Probably about a third of our energy efficiency was by replacing the existing fluorescent lights to LEDs. We installed approximately 550 light fixtures with Enocean occupancy sensors and daylighting sensors. We had a couple of really good partners here. LA Lighting and Enocean Controls were really great to work with. The lighting here was predominantly a retrofit solution. And looking at the photo to the left of the screen, the troughers that you see there, you basically gut the system out and you take the inside out and you screw in a retrofit LED module. So it's fairly simple and very quick. LA Lighting team were able to manufacture the retrofit solution within only a few weeks. And all of these lights are all integrated with light tubes that are also part of this project. I'd like you to look at the photo on the right. As you can see the color difference between the fluorescent and LED. The old existing light was quite yellow, whereas the new light is bright yellow and bright and very clear. Next. This is another example of before and after. You can see the difference in light. Okay, so Enocean Controls. The light tubes that we used on this project, Solar Tube, predominantly work with Lutron controls. Since we're using Enocean Controls on the LED lighting retrofit project, it made sense for us to use the same controls for light tubes. So we had several discussions with Solar Tube to integrate the light tubes with Enocean Controls. Solar Tube finally agreed. They came down and Enocean rep flew in to train our contractors how to integrate the system and work with Enocean Controls. Now that this model has been tested and it works together, it can easily be replicated on your project. Next slide. This photo shows you the startup process. As you can see, one of our team members, our control specialist, working on his laptop. He's calibrating the lights, the controls, and integration between various components, and he's also setting light levels. Being a pilot program, naturally, there were a lot of firsts on this project. So, for instance, I was just telling you, Solar Tube working with Enocean Controls. This was another first. With the training and the support that our team members received from Enocean and LA Lighting team, we gained a control specialist. This was his first project working as a control specialist, and after receiving several one-on-one training, he's pretty proficient as a control specialist now. Next slide. Installation of 18 light pipes began shortly after LED retrofit project. For this particular project, HMC was brought in to design the layout for the light tubes. I should point out that I'm using light tube and solar tube interchangeably. Solar Tube is the manufacturer of the light tubes, and their light tubes are being installed for this project. So it all comes down to energy saving, which is achieved by daylight harvesting. When it comes to Solar Tube, they make very nice stands. starting at the point where the sun is coming in, they have the ability to harvest light even when it is at a low angle. The optical dome that you see on the left captures daylight and directs it into the tube. It rejects bad UV. The domes are injected with UV inhibitors that do not allow harmful sunlight to enter the room. Solar tubes use highly reflective tube. It's about 99.7% reflective, and it allows daylight to travel long distances without any light loss. In general, it's only 0.3% of light is lost. The tube goes down from the lens to your attic space. It has a fair amount of flexibility, which is helpful when you're dealing with, say, ceiling obstruction. In a retrofit case like this, we had some ductwork in the way and beam conditions supporting the overhead roof mechanical screen. With the flexibility of the system, we were able to make the needed adjustments, as it allows for 90-degree bends as well as long bends. The flexibility works really well in the retrofit solution. For this project, we also took advantage of dimming controls that SolarTube offers. It has a low voltage motor, so you do have a wiring component that ties in the building lighting system. We wanted to give the room occupants ability to control what could be perceived as too much glare or too much light, and the ability to control that. Another thing that was really nice was using Enotion Controls wireless switches. In a retrofit condition, we did not have to go and open the walls, bury conduits, or go with surface-mounted wire conduits. Instead, we were able to use wireless rocker switches. Southern California Edison consultant Carl Konis with Agile Environment, who is also a USC professor, used a system called spectrometer spot measurement, which measures the quality of light. That's the picture on the top of the screen on the left. He explained that the biological effects of light on humans can be measured in equivalent melanopic lux, EML. Carl indicated that Well Building Standard recommends a target of 150 to 240 EML for office space. But in our office workstation, before the changeover to LEDs, EML measured at 98. This measure was then taken after installation of light tube, and it was brought up to 269, which led to a greater potential for circadian stimulus and alertness. This was achieved by daylighting coming from SolarTube. This measurement supported the design goal that workstations near SolarTubes can be primarily lit with daylight during daylight hours, even with blinds completely closed. The HVAC replacement project involved installation of 5 ultra-high efficiency HVAC units in the district office and 3 high-efficiency units at the Applied Technology Training Center, as well as adding CO2 sensors for demand control ventilation. We also upgraded the existing outdated building energy management system with new state-of-the-art controls capable of monitoring and controlling the new VAV package units, room thermostat, VAV boxes, CO2 sensors, and all the associated system. I have another slide on the BMS system. Next. Okay, so utilizing Southern California Gas midstream program, we replaced existing storage gas water heater with new Navien tankless high efficiency gas water heater. It looks really beautiful and it takes a lot less space, but more importantly, people were really enjoying having instantaneous access to hot water. In the district office training classrooms, all the window shades throughout the day remained closed. As you can see, they were high up and they were very difficult to access. And also this was due to east and west facing solar orientation of the windows. So we installed automatic shade devices to minimize lighting operation during daylight hours. MecoShade and ThermoShade worked together for the first time to provide automated solar shading operation with daylight wireless sensors in the classrooms and offices. ThermoShade is the pre-shade thermal barrier that blocks heat from entering the room in the summer, and it blocks it from exiting the room in the winter. MecoShade allows for more light or less light. Measurements and verification began after installation of this system. Onset was installed to monitor and diagnose electrical consumption of HVAC and lighting system. The top picture is the electrical current transformer that measures the electrical consumption of the circuit. Bottom picture shows you the weather station. The two charts on the left show you the electrical consumption in the two buildings. The BMS system was upgraded to newer hardware and programming of advanced algorithms. By employing CO2 and occupancy strategies during scheduled building operating times, we're keeping the spaces at set points when occupied, and when the spaces are vacant, the set points are relaxed to save energy from unneeded cooling and heating until the spaces are occupied again. By the way, even our occupancy sensors installed for this project were solar powered. So we only have to install plug load for vending machines. So we're planning to install these devices to de-energize the vending machines when no one is there to use it. So that's coming up this month. And then also the next slide. Pre-coolers. We have already installed 3 pre-coolers by ICI for this project, and we have 3 additional to be installed soon. I will speak more about these in our next webinar as we actually get to see their function. But pre-coolers in general increase cooling capacity by reducing the condensing temperature and the cooling load. Pre-coolers cool the air entering the condenser coil of the air conditioning unit, which means it increases the cooling capacity of the unit. So with all the lessons learned from the pilot program, we're going to be rolling it out into our campuses. SunPower has designed a 2.3 megawatt solar carport and rooftop system for San Bernardino Valley College. Carports have been designed to allow to use all low voltage LED lighting under canopies. We will also have EV charging stations distributed throughout parking lots of the campus. Solar array will also be paired with battery storage systems. The use of battery storage will allow us to capture excess energy generated during the middle of the day. Energy can then be used to offset peak time of use electricity charges in late afternoon or early evening. It can also be used to decrease facility-related and time of use-related peak demand charges. In other words, battery energy storage can be used to shave the peak so that you don't get penalized with a higher electrical rate. In addition, at night, you don't have to buy electricity from Edison. You can just use your store energy. And that's all I have to share with you today. Back to you, Riley. Thank you.
Thank you both. Thank you, Farah, and thank you, Philip. So we have 6 minutes for some questions. I will pass it off to Connie to read them out, and then Farah and Philip, feel free to respond.
Okay, we'll start with an easy one. Philip, what energy modeling software do you use?
Open Studio.
Okay. We have another question for excuse me. I said it was easy. We have one here. Why was the EUI reduction on Broomfield not greater?
Not greater. Good question. Let me just pull up what it was. So I can tell you, let me see, let me pull up the before and after for that one. So, you know, Broomfield Heights Middle School went from 61 to 37, which is pretty dramatic. But you might be asking about Broomfield High School, which is maybe the one that went from a 68 to a 58. And I don't know how to get back to that slide to show you guys that, but Broomfield Heights Middle School, I think was pretty dramatic. And what we did to get from a 61 to a 37 was really, we gutted the mechanical system, which is pretty much packaged rooftop units, and put in a chilled beam system with dedicated outside air, and putting chilled beams throughout the entire classroom space throughout that really did provide a huge amount of savings. We also put in LEDs and some pretty good control strategies. Broomfield High School, there's a pretty limited project there. You know, we might argue that that one is, you know, not quite into the deep energy retrofit space, in that we weren't able to touch as much of that. Go one more back. wasn't able to touch that facility as much. Yeah, here you go. So the second one from the left is Broomfield Heights Middle School, 61 to 37, and then the one next to it is Broomfield High School. And we just weren't able to impact as much on that school with what we had for bond dollars. That's a big high school, and so we only got to touch a portion of the building.
Okay. Can you elaborate a little more on active energy management? Was the education and training institutionalized for savings persistence?
Yeah, and this gets absolutely, and this gets back to like the that sort of continuity from the audit and design phase all the way through post-occupancy. So a couple things I'll talk about, and I'll elaborate on active energy management, is that when we were commissioning these schools, as we built our commissioning reports and as we were performing our point-to-point functional performance testing, all that good stuff, we were building those assets and that asset performance expectations into the school district's work order management system, their asset management and like their CMMS. And so the facilities and operations staff and technicians were actually getting a bridge built between the construction handoff and operations, so that when they inherited this information, they got it in a way that had all of the basically detailed information for them to operate the systems properly. Meaning we basically said, hey, here's what the CFMs should be, here's what the flow should be, here's what the sequences should look like. We sort of detailed that out in a very visible way to all the staff at the school district. And then we also put QR tags on all the equipment so that when they're out in the field, they could scan that with their phone or iPad and be able to pull up the information I'm talking about. That was what we did that to build into, to get to answer your question, this active energy management approach, which that phrase is the McKinstry term, the company I work for, which is a more or less a monitoring-based commissioning program, where we're basically writing analytics taking all the building automation system data, porting that in real time into a database, writing algorithms that analyze that automation system information and look for deviations in performance. And then that information is given to our commissioning engineer, who then works with the district to actually fix those problems that are coming up and tune and dial in the building over that 1 year period. During that's a really important piece. It's not a software program. It's an actual engagement program so by the time a year's over, really they're owning all that. It's their data. It's their, they've got visibility into. We've built the data into their systems now, so that they can take that and run with it moving forward. So they've got the capacity to do that.
Okay, we're going to ask one more question before we close out today. In coastal Oregon, estimates for solar payback is actually taking longer than the life of the panels, causing most districts to avoid it as they see it as a poor use of tax money. In states with 100% renewable goals, is supplementary energy still a good use of money in schools, or would that money be better in other parts of the facility?
Farrah, do you want to jump on that? I'm happy to speak to it, but you guys were talking about solar there.
Actually, you can go ahead and take it, because I would always say that the best money is spent on zero net energy.
Yeah, it's an interesting question, because if the net present value of the investment is negative at the time of the panel's life being extended, so if it's what I heard in that question was, it's a 30-year payback on a life of a panel that's 25 years. I mean, honestly, my recommendation would be something's wrong with that, right? You shouldn't. I wouldn't invest in that if it had a negative return. I guess I would say, we always look at the cost curve, as Farrah pointed out, between energy efficiency. It's generally more cost effective up to some degree till you look at the flip over point to when you want to start investing in some type of on-site renewables. I would say if you're in the situation where you've got this sort of negative net present value problem, I would look to other models. I'd look to PPA models where you're not looking at an ownership model but a rental model, or I'd look to a subscription model or a community solar model or solar garden model. if in your area there in Oregon, if you've got that issue. Although I am surprised to hear that, I guess, having done some projects in Oregon. Be happy to talk offline, whoever that was, to figure out what's going on with the math there, because that's not what I'm seeing with the trust there in Oregon.
I think it also depends on utility rates too and the operating hours.
All right. Well, thank you very much. Thank you to Farah and Philip for joining us today for this presentation. Riley, did you have anything to add?
No, this was great. Thank you guys so much. And thank you all for tuning in.
All right. Have a great afternoon, everyone.